Hello everyone, welcome to my channel. This is Karuna teaching the course Computer Architecture and Organization. Fourth unit contains the following topics, out of which in this video we will concentrate on interface circuits. Introduction. Let us see. Interface circuit contains the following blocks: address decoder, control circuits and data status as well as control registers. You know, already we have discussed about this in previous video. This is the input device. We can connect IO devices, out of which here we are concentrating on input device. Okay, so that's what here the data is taking from the input device in this direction. Okay, now here bus is used to connect the input device through IO interface circuit. Bus contains address bus, data bus and control bus. Those are used to carry the address lines, data lines as well as control lines. Okay, next here address decoder is used to recognize the addressed device, and the control circuits are used to issue the required control signals to perform the data transfer operation. And here data register, you know what are the data registers? Data in register and data out register. Status register contains the relevant status bits. Okay, likewise this kind of interface circuit is used to coordinate the data transfer operation between input device and bus. Okay, so anyway here all the data registers or buffers are used to store the data, and status registers are used to indicate the status of the data available in the data registers. And here this transmission, we can say transmission is known as parallel transmission. Okay, so here the data transmitted parallelly because all wires carries all the bits simultaneously. That's what this transfer of data, we can say parallel transmission of data. Okay, so we can say this interface circuit is also known as port. Okay, so we have two types of ports. Those are parallel port and serial port. Okay, it is used to send the data bits simultaneously. That's what this kind of setup is known as parallel port. This IO interface is used to coordinate all the activities of the input device and bus. Now let us take one example how the data transfer takes place between processor and keyboard. Previously we have seen this is the interface circuit required between input device and bus. Okay, let us go in detail. What are the signals or how the transfer operation is performed between input device and processor through interface circuit in detail. Okay, so let us see the example. This is interface between keyboard and processor. Okay, so here this is interfacing circuit. That's what here we are using keyboard as a input device. That's what this interface is known as input interface. Okay, so this block contains the following parts: keyboard switches. Here we are considering a mechanical switches. Okay, so keyboard having keys, those are mechanical switches, and encoder and debouncing circuit. Okay, so this is interface circuit, you know already, which contains data in register and SIN flag. Okay, next processor. These are the control signals. Read write is the control signal, and master ready signal, slave ready signal. These are asynchronous bus. Here these are known as handshake signals. To perform these operations we use asynchronous bus between processor and keyboard. Data bus, nothing but group of lines which carry data bits. Okay, so because of that reading operation, the bus direction is in this way. Okay, so from keyboard to data is coming from keyboard to processor. Okay, to perform read operation the direction of bus is like this. Okay, so before going to perform operation where the data is to be read. Okay, so that processor needs to send the address of the data to the keyboard device through address bus. Okay, so the address bus direction is like this. Address bus is used to carry the address lines. Okay, you know this is control signal, which direction data is to be flown. Okay, so that means read or write. Okay, so here in this case processor wants to perform read operation. That's what here read or write bar is equal to 1. Okay, whenever this signal is 1, then it perform read operation. Whenever this signal is 0, that means W bar, that means write operation. Okay, whenever this signal is 0, then perform write operation. In this case this signal is always 1 to perform read operation. Okay, let us see how processor read the data. Okay, keyboard, whenever you press the key, okay, that corresponding character code will be loaded into the data in register. At the same time valid bit will be set to 1. Whatever the key is pressed, the encoder circuit translate whatever the pressed key to the corresponding code, ASCII code, that will be loaded into data in. Okay, so whenever you press the key, that corresponding character, ASCII character code will be loaded into data in register with the help of this encoder circuit. Okay, here debouncing circuit. Problem may occur while typing some characters with the help of keyboard. Key bouncing, that means whenever you press the key, pressed or released frequently, sometimes the key may not be displayed on the display device, or the key may be displayed continuously on the display device. So that is known as key bouncing. Okay, to avoid that key bouncing, we will use debouncing circuit. Okay, that is the operation of debouncing circuit. It is used to avoid bouncing of the key. So whenever data is transferred to the data in register, SN flag will be set to 1. Okay, so here processor always monitor whether SN is equal to 1 or not. Okay, so if it is 1, processor collects the data from the data in register through data bus, okay, to its register. Okay, likewise read operation is performed. Before that, some handshake signals are used. Initially processor sends the address to the keyboard to access the keyboard. Okay, so here after that processor issues read signal. Okay, then whenever processor is ready to receive the data, master ready signal will be issued by the processor. Okay, so here whenever the keyboard, or we can say input interface having input interface data in register having the data, that then it will send the slave ready signal to the processor. Okay, so likewise read operation is performed by the processor with the help of asynchronous bus and some control signals, address bus, data bus and valid bit. So whenever a processor received the data from data in register, immediately SN will be reset to 0. Okay, SN will be set to 0. Whenever data is full in data in register, SN will be set to 1. After performing read operation, immediately SN will be set to 0. Okay, likewise data read operation is performed by the processor. Let us move on to the next slide. Here interface circuit. Okay, so here just we have seen the blocks between keyboard and processor. As observe what kind of circuits are used to perform this operation in detail. We'll tell you what are the parts existed in this interface circuit: data in register, status flag, SIN, read status, read data, slave ready signal, whatever we have seen in previous slide. Handshake signals are slave ready, master ready and read write signal, and here data lines are D0 to D7, address lines are A1 to A31, means here 32 address lines are there to recognize the address device. A1 to A31 are used. Okay, so here A0 pin is connected to D0 bit to read the SIN bit through D0 line. Okay, so these are the connections required to perform read operation between keyboard and processor. Here let us see one by one. Initially processor sends the address, okay, through address lines. Then address decoder used to recognize whatever the address device. Okay, now whenever a keyboard is recognized, then keyboard will respond. Here whenever you press the key, corresponding code will be transferred through data lines D0 to D7. Okay, that code will be loaded into data in register. At the same time the valid signal will be high. Okay, then SN flag bit will be set to 1. A0 determines whether D0 line is connected to SN bit. Processor reads the status bit through D0 line. Okay, after that read the data D0 to D7. Okay, first processor reads the status bit through D0 line. After some time data read by the processor through D0 to D7. Okay, that's what here A0 pin is used to determines whether D0 is status bit or data bit, D0 bit of the data. Okay, so that's what this is connected to A0. Okay, here the status of this flag may depend on coming signal, valid signal, and read data and master slave ready signal. So the status flag updated based on the providing inputs, read data, master slave, valid signal. Now whenever the key is pressed, the data is transferred to the data lines of the processor. D0 to D7 lines are connected to the processor. Data transferred to the processor through the buffers, tri-state buffers. Okay, those will be activated by the read data. That read data will be activated based on the inputs provided on AND gate. Okay, likewise here read status also updated based on the inputs, okay, provided in the next AND gate. Okay, so whenever this read status and read data are high, then slave ready signal will be issued to the processor. Okay, these are all connected at the processor side and these are all coming from keyboard. Okay, so those signals are coming from keyboard, these signals are connected to the processor side. Okay, likewise here whenever key is pressed, the corresponding character code will be transferred to the processor D0 to D7 by issuing the valid signal is 1, then SN will be set to 1. Whenever processor reads the data, then SN will be set to 0. Okay, likewise operation is performed with the help of interfacing circuit. Let us see how status flag or status of the data depends on this read data, valid data and master ready signal. Let us see how the status flag will be set to 1 when the read operation is performed. I told you here status of the data depends on read data, master ready and valid signal. Okay, here we use D flip-flop, which is edge triggered flip-flop. Here SN is equal to 1 only while master ready signal is 0. Okay, and see another point you have to note that both D flip-flop and latch are reset to 0 when read data is equal to 1. Okay, like that the circuit is designed. Here the status flag set or reset based on these conditions. Okay, let us see one by one. For example, here master ready signal is 0. Okay, here read data is 0. Okay, whenever key is pressed, then the valid signal will be provided by the keyboard. Okay, whenever the key is pressed, the data is transferred to the data in register, immediately valid bit will be set to or changed from 0 to 1. Okay, so here D flip flop is edge triggered flip flop. These pulses are coming from the clock cycles. Okay, I told you this is level triggered and this is edge triggered. Okay, whenever this edge occur, then D flip-flop will be set to 1. That's what this is known as edge triggered D flip-flop. Okay, so here whenever valid signal is 1, key is pressed and valid signal is set to 1, then output of the D flip-flop is 1. Okay, so master read is initially 0, then output of this is 1, 1, 1. Here we use NOR latch, okay, to set the status flag. D flip-flop and NOR latch we use. Whenever valid bit is equal to 1, then the D flip-flop will be the D flip-flop output will be 1. Okay, here master ready signal is 0, then due to this NOT gate, 0 become 1. Okay, then two inputs are 1, AND gate output is 1. Okay, now output of NOR gate is 0. Okay, now this 0 is transferred to this NOR gate. Okay, then read data is 0. If NOR gate inputs 0, then output is 1. Okay, likewise SN bit will be set to 1. Whenever data is available in the data in register, SN bit will be set to 1 based on valid signal, master ready signal and read data. For example, after completion of the read operation, this status flag will be set to 0. Let us see how it will possible. Okay, so here while reading the data, read data is equal to 1. Here I told you next is D flip-flop and latch are reset to 0 when read data is equal to 1. Okay, so read data is equal to 1, then the output of this NOT gate is 0. Initially this is 0. Read data is 1. Okay, see here data flip-flop and latches are reset to 0 when read data is equal to 1. Okay, so read data is equal to 1, then output of this NOT gate is 0, that is transferred to the D flip-flop, then output of D flip-flop is 0, then D flip-flop will be cleared. Okay, the output of D flip-flop is 0, then here 1 0 0 output of this AND gate is 0. Okay, so initially here we are discussing about SN is equal to 0. Okay, that SN is 0 is acts as a input of this NOR gate, then output of this NOR gate is 1, then 1. Okay, because of this read data 1, then output of NOR gate is 0. Likewise SN bit will be set or reset based on the signal provided by the master ready signal, read data and valid data. Let us move on to the next slide. Printer to processor connection. Likewise write operation can be, in this case processor and printer. This is output interface. Printer is output device. That's what this interface circuit is known as the output interface circuit. Okay, here processor needs to send the data. That's what data lines directions are like this. Okay, so here also data lines are towards printer. Okay, whenever the data is available in data out register, valid signal will be issued to the printer. That indicates here is a valid data available in the data out register. Okay, read write signal is the control signal. Before going to perform write operation, processor sends the write signal to the printer. Okay, so you know these are the handshake signals. Whenever processor is ready to send the data to the printer, then master ready signal is issued by the processor. Okay, whenever printer is ready to print the data, then slave ready signal is issued by the printer to the processor. Okay, so here whenever the data is available, then valid signal will be set to 1, then printer issue ideal signal to the processor. That indicates printer is ready to display the another character. Likewise, write operation is performed with the help of this output interface circuit. This is the detailed interface circuit exists between processor and printer. Okay, so here these are the lines connected from the processor and these are lines issued by the printer. Okay, next So I told you interface circuits are two types. Interface circuit also known as port. Okay, so two types of ports, parallel port and serial port. This case comes under parallel port. Okay, we can say this is parallel transmission of data. Okay, because data lines are D0 to D7, those lines will carry the 8 bits at a time. That's what this kind of operation is known as parallel transmission operation. Okay, so we can say this interface circuit is known as parallel interface circuit. Okay, so let us see the combination of both input and output diagram. Okay, see here data lines are used to transmit the data in or out decided by the data direction register. Okay, so P0 to P7 or lines are connected from IO devices. D0 to D7 lines are connected between processor and interface circuit. Okay, so these registers are selected. Here register select device is there. Registers are selected with the help of R0, RS1, RS2. Okay, read write signal is issued by the processor. These signals are all coming from the processor. Okay, ready signal, accept signal, these we can say handshake signals. Okay, my address nothing but processor issues the address. Whenever the signal is high, the address will be transferred from processor to the IO devices to recognize the address device. Okay, so here C1 and C2 control signals are used to control the interaction between the interface circuit and IO devices. Interrupt signal, you know, this is connected from status and control flag, it issued from the IO devices to the processor. This is the general 8-bit parallel interface or parallel port used to perform data transmission in and out. Next, coming to the serial port. So with the help of serial port, single bit can be transmitted at a time. That's what we can say, bits are transmitted in serial fashion. Okay, so here our processor is parallel. Processor is having parallel port. If the serial interface is used, we need to convert from parallel to serial data in case of output data transmission. In case of input data transmission, we have to convert from serial to parallel. Okay, so to convert serial to parallel, parallel to serial, we need shift registers. Okay, let us see the interface circuit which is used to transmit the bits one by one. Okay, so here I told you, case of serial transmission, shift registers are required. Okay, so these are all, you know, control signals issued by the processors. Data lines are issued by the processor. Here data in register, data out register. Data in register is used in case of accessing the data from the keyboard or from outside world. Data out register is used to send the data to the outside world by the processor. Okay, so whenever data is coming from outside world in serial fashion, input shift register used to convert that serial bits to the parallel bits, because data in and data out registers perform parallel operation. Okay, so coming to the output data transmission. Okay, so for example, processor wants to send the data to the outside world in serial fashion. So data out register is parallel. After getting data into data out register, then those parallel bits will be converted into serial bits. One by one the bits are to be transferred. That's what here output shift register is used. That output register, shift register is used to convert parallel bit transmission to serial bit transmission. That's what here we are mentioning serial output. In this case serial input. Okay, so here processor takes the input serial fashion. Here processor sends the output in serial fashion. Okay, to perform that serial data transmission operation, we will go for serial interface circuit between processor and IO devices. Let us summarize the topic. To perform IO operation, IO interface circuit is used. Okay, that is used to coordinate the activities between IO devices and the bus. Okay, you know already bus contains address bus, data bus, control bus, which are used to carry address bits, data bits and control signals. Okay, so in case of keyboard interface circuit, we have seen how the data transmission takes place between keyboard and processor, and also we have seen how the data transmission takes place between processor and printer. Okay, so and also we have discussed about the difference between parallel port and serial port. In case of parallel port, all the bits are transmitted simultaneously or at the same time in case of parallel port. Okay, in case of serial port, data are transferred in serial fashion. That is the difference between parallel and serial port. According to our application, we can go any type of port or interface. Okay, let us move on to the questionnaire slide. What is the use of valid signal? What is the difference between parallel and serial interface? Next question, what are the control signals are used in keyboard interface circuit? Thank you. We will meet in next video.